Okay, so the mean value theorem is a theorem that we're going to use that will help us to just kind of locate what's going on inside a derivative. And what we're going to do is we're going to set the derivative equal to a specific point where that point is equal to the slope. And remember, slope is just y minus y1, y1 minus y1 over x1 minus, well, let's go y1 minus y2 over x1 minus x2. This is slope. And that's what this guy is. And remember, slope is also derivative. So what we're going to do is we're going to find a derivative that's kind of equal to itself over a given interval. So let's just take this guy, f of x equals x squared. And what we want to do is find the derivative. So, f prime of x is equal to 2x. There's your derivative. That's not too hard. But now what we want to do is we want to look at it specifically on the interval from 0 to 2. Okay? And so when we do that, we want to know with a and b, we want to know f of b, f of 2, minus f of a, 0, divided by b minus a. This is what we want to know. Okay, and so what we're going to do is we're going to take this, and here it is. Look right here. Here's the mean value theorem. Here it is right here. So what we want to do is we want to take this guy, and we want to set it equal to our derivative. And that's all you're doing here. So it looks weird, but we're just going, where is this a true statement? Where does this happen? And so now just do some math. We would say that 2x is equal to f of 2, in other words, 2 squared minus 0 squared, divided by 2. And so this is going to be 4 divided by 2. And 4 divided by 2 is 2. So 2x equals 2. Well, where does this happen? And it happens when x equals 1. So what this is telling us is that the tangent line 2x squared at x equals 1 has a slope of 2, and it just is satisfying the mean value theorem. In other words, if y equals f of x, which is y equals x squared, is continuous at every point on a closed interval and differentiable at every point, then there's at least one place, the C value, where you have this true statement that we talked about to start off with. And so we're just using the mean value theorem, the average value of the graph. And for this particular one, it's going to be x equals 1. Alright, so we want to talk about now why these two functions won't work, and why the functions fail to satisfy the conditions for the mean value theorem on the closed interval from -1 to 1. Well, if you look at this first function right here, what's going on is if you take the square root of x squared, basically no matter what happens, you're just going to have the absolute value of x. And if you think about that graph, that looks like this. Well, one of the rules for the mean value theorem was that you had to be differentiable at every point on the interval from -1 to 1. And there are 4 places you cannot take a derivative, and one of those places happens to be at a point. When you have that curvy point, like corner, a corner is a better way to say it. And because this happens, you cannot take a derivative of the square root of x squared plus 1 at 0. And since you can't do that, the mean value theorem won't work. We can't find that average. If you look over here at the other guy, and we were to graph it, x cubed plus 3 for x is less than 1. So we're really interested now in what's going on at 1. Well, I know x cubed plus 3 is going to look something like this, and at 1 we are undefined. And then x squared plus 1 is going to be the x squared but up a unit, and so it actually is going to end up looking like this. if you put your x squared part on it. And so again, what happens? You've got a jump discontinuity, and because you have a jump discontinuity, the mean value theorem will not work. Why? Because we cannot take the derivative at the point that we're interested in. And since we can't take that derivative, we can't do the mean value theorem. Okay? So you've got to be continuous and differentiable on your interval. Continuous on the closed interval, differentiable on the open interval. And we don't have either one of those. We're missing one of those pieces on both of these problems. Alright, the next big deal for this section is to determine where functions are increasing and decreasing. And you can tell where a function increases or decreases based on the derivative. So we've got some rules here. If your derivative is greater than 0, you're increasing. If your derivative is less than 0, you're decreasing. And if your derivative is equal to 0, you're constant. So let's just look at f prime real quick, or y prime of these two guys, and talk about what's going on. So alright, so with y equals 2x, basically we're going to set 2x equal to 0, and we get a critical point of 0. And just draw out a number line real quick, put your critical point in there, 0, and we'll list our 2x over here, and what we're going to do is we're going to make a sign chart. And so pick a number less than 0, like say -1. And when I put -1 in for x, I get 2 times -1, which gives me a negative number. Okay? A negative number. And then pick a number bigger than 0, like say 1, and put that in for x, and that gets me 2 times 1, which is a positive number. So, where does the function decrease or increase? Well, my derivative is less than 0 when x is less than 0. And my derivative is greater than 0 when x is greater than 0. And so where does this function increase or decrease? Right here. This is where the function decreases and increases. Okay? So let's look at this guy right here. Set this guy equal to 0. 3x squared minus 4 equals 0. 3x squared equals 4. So x squared equals 4/3. So what have we got? We've got plus or minus 2 over the square root of 3. And so again, set up a number line. And with your number line, we're now going to look at critical points of -2 over root 3 and +2 over root 3. And so I don't need to know a lot here of what's going on. I don't need to memorize my roots, but put this in. So what you want to do then is you just want to check values of x that fall in these intervals. Well, I know 0 falls here. I know that if I go far enough outside, I could use a number like, say, -2 over here and +2 over here. So we just want to check these in my function to find out, what it does to my numbers. So when I put -2 in to my derivative, okay, so we're checking with 3x squared minus 4. And when I put -2 in, that gives me 4 times 3 is 12, minus 4, so this is going to give me a positive number. When I put 0 in, I get a negative number. And when I put 2 in, again, I get this positive number. So on this guy, where's the function decreasing? It's decreasing where the derivative is decreasing. So for this function, x cubed minus 4x minus 1, it decreases from -2 root 3 to 2 root 3. It increases from -infinity to 2 over root 3, together with 2 over root 3 to infinity. So don't let this be really hard. You're still taking the derivative, you're still setting it to 0, but now we're making a little sign chart here to help you organize where the graph is positive or negative.